Hello and welcome to the solution series for GATE 2025. We are at question 36. This is a 2-mark question. It falls under atomic physics and quantum mechanics. The problem asks us to calculate the first ionization potential of helium using the concept of screened nuclear charge within the framework of the Bohr model. We have 4 options to choose from. The question states that the screened nuclear charge of a neutral helium atom is 1.7 electrons. We are given the Bohr energy formula in atomic units, that is En equal to Z squared over twice n squared. We need to find the first ionization potential of helium, and remember, the first ionization potential is the energy required to remove the first electron from the neutral atom, taking it from the ground state to infinity. Mathematically, this is the difference between the energy of the final state, that is the helium plus ion, and the initial state, that is the neutral helium atom. First, let's calculate the energy of the initial state, the neutral helium atom. In the independent particle approximation, which the Bohr model implies here, we treat the 2 electrons as occupying the n equal to 1 shell, but seeing a reduced nuclear charge due to screening. Using the Z effective, which is 1.7, the energy of each electron is simply 1.7 squared over 2. And since there are 2 electrons, the total energy of the neutral atom is 2 times 1.7 squared divided by 2. So n is 1. So the factor of 2 cancels out, leaving us with 1.7 squared. And 1.7 squared is approximately equal to 2.89. Alright, so the total ground state energy of helium is minus 2.89 atomic units. Alright, now consider the final state. We have removed 1 electron, so we are left with helium plus ion. This is a single electron system, basically a hydrogen like system. Crucially, since there is no other electron to shield the electrons, the remaining electron sees the full nuclear charge, that is Z equal to 2, and we cannot use Z equal to 1.7 here. The screening was caused by the electron we just removed, so there is no screening. Alright, so using Z equal to 2 in the Bohr formula, that is minus 2 squared over 2, so we are having minus 4 by 2 is equal to minus 2 atomic units. So the final state has minus 2 atomic units. Finally, we calculate the ionization potential. So it is the final energy minus the initial energy. This is nothing but the ionization potential. So we substitute the E final and E initial we just found out in previous 2 slides, which is minus 2 and minus 2.89. Our ionization potential is positive 0.89. So looking at our options, it matches option A. If you just look at option here, it is simply option A. So note that the value of 0.89 atomic units, it corresponds to about 24.2 electron volt, which is very close to the experimental ionization energy of helium, which is 24.6 electron volt. So that confirms our method is correct. So let us look at a key takeaway here, which is to remember that screening depends on the number of electrons. So screening depends on number of electrons. In the neutral atom, electrons screen each other, so therefore Z was 1.7. Once you ionize it, the remaining electron sees the bare nucleus, so Z equal to 2 Ks. So don't forget to update your Z value for the final state. So that's quite important. So check out the lectures on the electronic transitions in diatomic molecules in the Atomic and Molecular Physics course by Professor Das. And that's it for this particular question. I'll see you in the next one.